Okay, so here we are with a quick lesson about the particle theory of matter as it pertains to what we're going to see the rest of this unit, the rest of this chemistry unit. The particle theory of matter has 5 points, and we use an acronym PISAM, to help us remember what the 5 points of the particle theory matter are. Okay, so the first is that all matter is made of particles. Okay, so that's the first point of the particle theory of matter. And so there's lots of examples of this. A particle could be an atom, or it could be a molecule. Either or is fine. And matter is going to be made up of these two things. So for example, 24 karat or pure gold is made up of gold atoms. Okay, so in this sample that we have here, 4 gold atoms are shown. And so this kind of demonstrates that this chunk of matter is made up of particles. It's made up of atoms. A little bit of a different example. Ice is made up of H2O molecules. Okay, so in this example, 6 water molecules are shown. And a molecule is made up of, in this case, 2 hydrogen atoms and 1 oxygen atom. And that's where the 2 comes from. There's 2 hydrogens and there's 1 oxygen. Jewelry gold, so 14 karat gold, which is a little bit different, is actually a combination, 60% gold atoms and 40% copper. And so we might get a sample that looks something like this, where we get gold and copper mixed together. So this is a mixture, which is an impure sample. This is made up of gold and copper atoms. So a different kind, but we can still see that it's a hunk of matter and it's made up of atoms, so particles. And last but not least, a balloon filled with helium, and this is a sample that's made up of 5 helium atoms. Okay. So the second point that we have is that all particles in a pure substance are identical. Okay, so if we have a pure substance, all the particles in a pure substance are identical. If the particle is made of only one type of atom, then the substance is called an element. Right? And so other examples of this you can see on the periodic table of the elements. So if a particle is made of only one type of atom, so for example, up here we had gold and we had helium, those are elements. And if the particle is made up of only one type of molecule, then the substance is called a compound. So if we look at a few of the examples from above, we can see that a sample of pure gold is made up of only atoms, so we would call that an element, where the sample of distilled water is made up of only H2O molecules, so we would call that one a compound. But a sample of pure table salt is made up of only NaCl, sodium chloride molecules, so we would call that a compound. Okay. However, if we were to mix salt and water, we notice that that's made up of a mixture, H2O molecules and salt molecules and that gives us a mixture. So we have a little bit of a difference, and that is an impure substance. And so that's why this word is highlighted here or bolded. It's an impure substance. And you can see that an impure substance, these are not identical. NaCl and H2O are not identical, so that's an impure substance. But a pure substance has particles that are identical. All right, the third point, the S, we've done the P, the I. The S is that there's space between the particles. And the spaces are very, very large in comparison to the particles themselves. So the atoms or molecules are very small in comparison to the space in between. If we heat up a sample, then the space between the particles increases, and we say that the substance expands. If we cool a sample down, then the spaces between the particles decrease, and the substance contracts. And we see this very, very often. We see it all the time in examples where we're looking at changes of state. And we're going to talk a little bit more about those changes of state tomorrow. The fourth point, PISA, the particles are attracted to each other. So if attractions between particles are broken, the substance changes state. Right? So we could melt, we could go from solid to a liquid, we could boil it, we could go from a liquid to a gas, and we could do the reverse of those things. So in a solid, a substance has a large number of attractions, and all the attractions that can be made are formed. In a liquid, though, we have fewer attractions. So we only have some attractions that remain. Some of them have been broken. And in a gas, we have virtually all of the attractions, or most of the attractions, are broken. Now, what are we talking about when we talk to particles being attracted to each other? This little diagram right here goes with what we're talking about. So here's an example. Here's water. And in water, we actually have attractions right here between the molecules of water. Okay? We're not talking about these attractions in here between the hydrogens and the oxygens. That's a chemical bond. We're going to talk more about that later on this unit, but we're not talking about those. We're talking about the attractions between the water molecules, and they actually are attracted to each other. Our last point in the particle theory is that all particles are in constant motion. And what we use to measure the speed of particle motion is temperature. So that's how we talk about this speed. Okay, we measure the speed of particle motion, or the temperature, with something called a thermometer, as you know. A particle speedometer, if you want to think about it that way. And we know that if we increase the temperature, then we increase the motion of the particles. If we decrease the temperature, then we decrease the motion of the particles. It's theorized that absolute zero, which is the lowest temperature we can get, it happens at minus 273.15 degrees Celsius, is the point at which all particle motion would stop. And there's a whole branch of physics called low temperature physics where we seek to achieve absolute zero, but of course it's theorized, it's a theoretical temperature. We can probably never actually get there, and we can talk about why in class. So there are your 5 points of the particle theory of matter in under 10 minutes.